On This Week in Enterprise Tech, all your servers belong to us. Verizon goes symmetrical, and everything you ever wanted to know about infinite storage. It's Coho Data, Twiat on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twiat. This Week in Enterprise Tech, episode 100, recorded July 21st, 2014. Coho Data. To infinite storage and beyond. This Week in Enterprise Tech is brought to you by Prosper. Prosper is a peer-to-peer lending marketplace that connects people who are looking to borrow money with those who have money to lend. Visit prosper.com/twit and receive a $50 Visa prepaid card when you get a loan. Welcome to Twiat, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Ballecer, the digital Jesuit, your guide to all things in the enterprise. And I'm joined by my fantastic cast of extraordinary gentlemen, starting with Mr. Brian Chee, the director of the Advanced Network Computing Laboratory in Honolulu, Hawaii, who, by the way, just celebrated his 17th anniversary of punching cancer in the face. Brian, how are you?
I'm doing fine. But, you know, last year was amazing. My wife pulled a Sweet 16 party for me and everything was pink. It was epic. This year, a little more sedate. I wake up and there's a card being shoved at me saying happy birthday.
Fantastic. Well, we're glad that you're still around because, well, we depend on you for some of the hardest hitting enterprise stuff. Now, also with us is Mr. Curtis Franklin. Curtis, you're on safari. What exactly is going on here?
Well, you know, sometimes you just decide that there are pieces of traditional male garb that need to be brought back. I feel that way about the pith helmet, so I'm doing what I can to make sure that this underappreciated piece of male headgear gets its time in the sun once again.
Well, gentlemen, we've got a fantastic show waiting for our viewers. We're going to be talking to Coho Data, who promises us web-scalable infinite data. But before we do that, let's jump into the news. We've got our first blip. Microsoft and Cisco sitting in a tree. Looking to get a bigger bite of the cloud, Cisco and Microsoft have expanded their 15-month collaboration trial into a 36-month deal. The arrangement will continue to bundle Microsoft Fast Track and the Cisco Unified Data Center, while also seeing both companies align their partner programs to incentivize their channel partners to push the Cisco-Microsoft hybrid as a one-stop shop for cloud and data center buildouts. Of special interest to Cisco Soft is the potentially lucrative migration of Windows Server 2003 customers to Windows Server 2012 R2 on the Cisco UCS platform.
And this blip comes from the Washington Post. Thank you very much. Patent trolls now account for 67% of all new patent lawsuits. Despite the sudden collapse of patent legislation in the Congress earlier this year, most policymakers agree that patent trolls are a huge drag on the U.S. economy. By filing one frivolous lawsuit after another, trolls exact enormous payments from companies simply by claiming infringement. They don't have to do very much to back up their assertions, nor do they have to be using the patents to sue. A new study from PricewaterhouseCoopers shows that the problem is getting worse. While monetary rewards from patent lawsuits are decreasing overall, patent trolls, also known as non-practicing entities, because they simply stockpile patents without making anything with them, are making way more off of litigation than their practicing counterparts. Even as the median award has shrunk over time, awards to trolls are only growing.
Now, Google might be bringing phone booths back to the future. New York is full of phone booths, but let's face it, no one uses them unless they're trying to escape some form of government surveillance. Now, Google is one of the companies looking to repurpose the old school connection points for the internet age by turning them into Wi-Fi hotspots. Now, there are other companies like Samsung that might be working to bring new life to the old boxes, but Google should have a leg up given its experience in providing Wi-Fi to San Francisco parks and Starbucks around the nation. While we're unlikely to see a return to the days in which you'd run to a payphone to check your messages when you left a meeting, it's possible that a new generation could be introduced to the wonders of communicating from a small box, with or without the addition of a big red cape.
Now, the only sure thing about life is death and taxes. Of course, unless, of course, you're on the internet, where we're working on that death thing, and I think we've got the taxes licked. Last week, the United States House of Representatives passed a bill that would make the current temporary ban on federal, state, and local taxation of internet access permanent. The creatively named Permanent Internet Tax Freedom Act would prohibit government agencies from taxing internet-specific services. The temporary tax ban was first signed into law by President Clinton in 1998, but at the time there were 7 states, Ohio, South Dakota, Texas, New Mexico, Wisconsin, Hawaii, and South Dakota, that were already charging tax for internet access, and they were allowed to continue. With the permanent ban, even those 7 states would now need to recognize access to the internet as untaxable. Well, let's get right to it. That was our blips. Now let's jump into our bites. The first one comes to us from the legal department, the DOJ. Evidently, Obama thinks that all your servers belong to us. In a closely followed legal battle, the Obama administration has claimed that any company that has operations in the United States must comply with warrants for data seizures, even if that data is stored in another country. The case centers around data that Microsoft has housed on servers in Ireland. In April, a magistrate judge agreed with the administration, ruling that an entity that has been lawfully compelled to turn over data must do so regardless of the physical location of that data. Microsoft appealed to a federal judge, and the case is to be heard on July 31st. Now, Chee, I want to throw this over to you first. Let's get some of the facts of the case, specifically what the government thinks their case is based on. The U.S. is basing their case on the 1986 Stored Communications Act. Specifically, let me quote this, the disclosure of records under circumstances that have never been considered tantamount to a physical search under Fourth Amendment principles, and Microsoft is mistaken to argue that the SCA provides for an overseas search here. As there is no overseas search or seizure, Microsoft's reliance on principles of extraterritoriality and comity fall wide of the mark. The important part is that the U.S. is saying that the data is not protected by the Fourth Amendment because there's no physicality, and therefore it's not protected from unusual seizure. Now, I know you're probably stewing a little bit, so let me get your input here. This sounds like an argument that the DOJ is making because, as they say, crime has evolved and now it's so easy to move data from one part of the world to the other that somehow the law of law enforcement must change. And this is a ham-fisted way to do that. Do we trust the DOJ here, or do we rail and say this is the worst thing ever?
You know, the Department of Justice really needs to start hiring some people that actually know what the heck they're doing. The reality is this is going to be just like what had happened in I think it was the 50s and 60s, when a lot of the tax legislation changed on how you do business in America, and we lost an awful lot of business. Department of Justice, please start looking at what you're doing and look beyond your nose. When you start making things that are saying, well, even if you do business in America, we're going to do something nasty to you, and we're going to do this in such a broad way that you have very little chance of defending yourself, you're going to start chasing business out of America. Do you want the American public, do you want the American economy to become a third world nation? Take a harder look at your rulings and get someone that actually works in the business to give you some advice.
That's long been a battle cry of people in IT, that we wish that when they were making these laws, when they were pushing these bills, they actually spoke to people who had to enact them, who had to turn that policy into something that was enforceable. However, I'm going to play devil's advocate here, Chee. The DOJ is right to be concerned about a legal shell game. It is really, really easy to move data physically from one jurisdiction to the next, even without human intervention. It could be all set up, automated as a script. So if that's the case, and if the DOJ was bound by the old principles of the Fourth Amendment in seizing physical property when going after virtual digital property, they could essentially never be able to claim the evidence of an interested party. There has to be a way around that as well, right? I mean, yeah, I understand how horribly this could be abused and how horribly this could be applied. But at the same time, do we need to give law enforcement something, some way to get access to this data that, within a reasonable amount of time?
Well, maybe, just, playing backseat driver here, if a judge issues a warrant for search and seizure, maybe that warrant needs to be served against the ISP first to put in blocking measures to prevent the data from moving. Once that's in place, then they go and do the seizure. One of the things you do when you're seizing a computer is you don't even power it off. Literally, I was instructed by 3-letter agencies that when we went into seize computers, we literally pull the power plug so that shutdown scripts can't happen. Of course, yeah, this does some damage, and a lot of people got really, really pissed off. But because we knew of this, we also made sure that that warrant really spelled out exactly what we were and were not allowed to do. There are ways around this. Let's get some experts in there that actually know what forensics is about and talk about it. In fact, there's a whole bunch of geeks that are going to be joining us, hopefully, in Las Vegas, and we can actually talk to them.
Curtis, I want to throw this over to you, because one of the things we always need to talk about whenever we have these sweeping laws and these sweeping decisions is the law of unintended consequences. I understand what they're trying to do. The DOJ is desperately looking for a way to have law enforcement in the world that is no longer bound by physical boundaries. It's so easy to move data from one place to another. But by saying that extraterritoriality does not apply when dealing with virtual evidence, virtual property, in other words, digital data, doesn't that also mean it goes the other way, that if another country asserts the right to data from a server in the United States because Microsoft, Google, or Apple have a presence in their country, that we should be legally bound to turn that over to them?
Oh, absolutely. I mean, this is one of those cases where jurisdictions around the world will now be able to assert the same sort of claim on data. You've heard me in the past, and I'm generally not someone who is in favor of law enforcement overreaching, but I do have some sympathy for them. Let's imagine a scenario where you have a company with an Active Directory domain that covers servers that are in the U.S. and, just for the heck of it, let's say the U.S., Ireland, Italy, and South Africa. But one domain, one Active Directory structure. Why should exactly where the data is living matters? It's all one logical grouping. Since cloud computing came in, those of us in the tech industry have really been preaching the idea that we wanted to get to a point where the data was abstract. You didn't have to care where the data lived. It was just in the cloud. Well, those words got to the Department of Justice, and they are essentially saying data is data. If your company controls it, if your organization controls it, then it's all the same. It is simply data in the cloud. And if your organization has a business presence within the US, then that cloud covers all of the data regardless of which hard disk it's actually sitting on. I understand the concept. As Brian said, I think we could very easily get into a realm of unintended consequences, but I'm not sure that they have reached as far afield as we think in this case. Looking at a data store as a single logical entity does make a lot of sense, even if it creates some very uncomfortable situations for a handful of companies.
Now, we're going to continue this topic in, I believe, 2 weeks when we're we're going to have a crossover between Twiet and This Week in Law. We want to handle all the enterprise law-related cases. But one of the additional pieces that I think needs to be brought into this is a few weeks back we talked about a report outlining the things that researchers thought would endanger the internet the most. And one of those things was fragmentation. I think that if any single government asserts the right to reach out through the internet, no matter where servers may be located, and assert the rules and laws of their country, we're inviting further fragmentation of the internet as these countries say, no, 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 no. We want something that's subject to our laws, something that's subject to our regulations, and something that another country will not be able to reach into. That's just something that we should consider. Let's move on to the second Enterprise Bite. We're talking about Google's Cybercrime Task Force. Now, this story needs a little bit of background. If we look over the last, say, 20 years of corporate response to gray hat hackers, we see that it's improved from the 80s and the 90s. Whereas in the 80s and 90s, hacker was synonymous with criminal, we've seen the Cold War de-escalate. Now, it's not perfect. AT&T pushed for the conviction of Weave, who found a security loophole on the AT&T website that exposed the information of thousands of iPad users. Microsoft sued a fair use hacker who exposed holes in their busted DRM. Apple is notorious for shotgunning cease and desist orders to anyone who dares peek under their hood. But then occasionally, you get a company that does it right. And that company now is Google. Now, let's talk specifically about a hacker by the name of George Hotz. If you've been running on in the scene, you know who he is. He's the guy who hacked the Sony PlayStation. He's the guy who was able to publish the first AT&T iPhone unlock, and he cracked Google's Chrome OS. Now, when he worked on the AT&T Apple crack, they ignored him. They tried to pretend like he didn't exist while they tried to patch the holes that he exploited. When he hacked the PS3, Sony sued him and made him promise not to ever hack their hardware again. Google took a different tact. They hired him. They paid him $150,000 for exposing the holes in Google Chrome OS, and now they've invited him to join a team of full-time elite hackers who hunt vulnerabilities in the software and services that drive the internet. Now, this is called Google's Project Zero. It's a group of top security researchers and hackers who spend all their time looking for zero-day vulnerabilities. The team is run by Google security engineer Chris Evans, and he's put together an elite team that includes Ben Hawks, who discovered bugs in Adobe Flash and Microsoft Office, Tavis Ormandy, who discovered zero-day flaws in antivirus software, Ian Beer, who discovered 6 bugs in iOS OS X and Safari, and of course, George Hotz, who's acting as the team's intern. The interesting angle here is that Google will be finding flaws in other companies' code as well as their own. I want to throw this over to you first, Cheebert. The idea here is that Google's trying to protect the internet. They believe that if people think the internet is safer, free of these zero-day bugs, that they're more willing to use the internet. And of course, Google makes money off people using the internet. Is this a sustainable business model?
I don't see why not. I've heard of teams like this that just aren't as public at a lot of different corporations. If you are a large corporation, you typically have a security team that may or may not have the talents to be able to go and find zero-day events. But boy, I tell you, anyone that's got the resources and got the funding will go and look for zero-day resources in whatever their corporation touches anyway. So in this case, Google, more power to you. Find those zero-day hacks, make it a safer place. Because boy, I tell you, there's an awful lot of people that don't want to touch the internet because they think just as soon as they connect, they're going to get hacked and their personal identifiable information is going to get misused for things like identity theft. So I can't see anything other than good coming out of this, but I can see Google's probably going to start running up against, folks like the NSA that don't like this. They want the vulnerabilities there, which I think is counterproductive to the good for the American economy.
Actually, let's talk a little bit about that. Curtis, one of the things that Google is known for, at least their security team, was when everything broke about the NSA and the spying, they actually had a public blog post that basically said, F the NSA, F this. They have publicly come out saying that they will do everything in their power to close all these zero-day exploits, all these bugs, so that the NSA cannot use them. Let me ask you this. This team is eventually going to be about 10 members, 10 elite hackers. It's going to have some of the resources of Google. But do you think they actually believe that they can close enough bugs to make a dent in what the NSA does? And do you think they believe they're immune to men in black coats coming over to have a chat with management?
Well, I suspect that they believe that they can close enough of the zero-day exploits to make the NSA have to work a lot harder. I think if you talk to them, they'd say that they really want to keep the NSA honest. If the NSA wants to work hard and find additional exploits and get in, God bless. But you don't have to hold the door open for them, which is what having lots of unexplored exploits or vulnerabilities tends to do. Now, as far as visits from men in black suits and dark glasses, I really do think that they are depending on Google's vast pot of cash to minimize those visits. Interestingly enough, it's also going to minimize the cease and desist letters from people like Apple and Sony. In the same way that engineers are covered by their employer's liability, this team is going to be covered by the vaunted legal department of Google. That's going to allow them to go into lots more places and find vulnerabilities in many, many more pieces of software. I think I'm not going to be surprised if we don't see an absolute wave of new vulnerabilities pointed out in the next 12 to 18 months.
Right. There's a discussion in the chat room right now on whether or not we trust Google. I don't think you have to trust the good intentions of Google. You trust that Google wants to make money. And they make money when people think that they can use the internet without having to fight off bugs and viruses. So this is in their best interest to be able to secure the internet. But Chee, I want to throw this over to you because this is something that Curtis brought up. The vaunted legal department of Google. Yes, it's a lot of money. Yes, it's a lot of resources that they can draw on. But one of the strengths of any hacker has always been anonymity, the ability to pound on a server, the ability to pound and probe a service from relatively anonymous tools. If they're all working for Google's Team Zero, they kind of lose that, right? I mean, if they're now a sanctioned team, everyone knows who they are. And one of their mission statements is that they don't just look at Google services, just at Google software. They're going to be hammering at the software and the services of their competitors. Not even a vaunted legal team can protect you against that. I mean, Microsoft seeing a bunch of Google IPs suddenly hammering Azure is probably going to raise a couple of notes in their legal department, right?
Well, yeah, but that's kind of a, shall we say, yeah, let's put it this way. The Google team has some resources that just aren't equaled anywhere else on Earth. You know, hackers use anonymizing networks, but what happens when you control some top-level routers? Now, all of a sudden, your digital footprint can be just about anything. You know, they could go and search for unused address space and use that and anonymize themselves like crazy. And, you know, Google's, you know, if you're talking about the legal team, just look at OJ. My goodness. When you have a dream team to defend you, you can, in theory, get away with anything as long as you can go and create some sort of doubt in the jury's mind. So I think these guys are, well, guys and girls maybe, are going to be able to do some really, really interesting things. And I don't think the fact that their names have been disclosed is going to be that big a deal.
Gentlemen, I want to do one last enterprise bite. I probably should move on, but this one I actually really like, and I do want to talk about it, and that's Verizon going symmetrical. Now, if you are one of the lucky few who has Verizon Fios, rejoice. You're getting symmetrical. Today, Verizon announced that they'll be upgrading its Fios subscribers to symmetrical speeds at no additional cost. That means that if you were on their 15 down, 5 up plan, you now get 15 megabits per second in both directions. The same thing goes for their 50-25 and 75-35 plans. Now, Chee, aside from the fact that this is very exciting, and aside from the fact that it's also very disappointing because Fios is available in so relatively few parts of the country, symmetrical access was never a selling point for ISPs until Google started to threaten them. Google Fiber is 1 gigabit symmetrical, and people are actually starting to see that that's a good thing. It means that they can upload faster. It means that they can video chat more quickly. And it means that they can quickly back up their terabytes of data into the cloud. Is this now a win change, a sea change? Will we see Comcast, Time Warner, and AT&T slowly change their view because symmetrical is now going to be the thing to have?
Well, I think I'm looking more from what's pushing this. And I think what's pushing this is America is made up of one heck of a lot of small businesses. And more people are running businesses out of their homes or out of their small offices. Having symmetrical means you can do an awful lot more. You can run a tech support site. You can run a video server. You can run video conferencing. There's a lot of stuff that can be done. And not being able to run a lot of these services has been, shall we say, an impediment to the growth of the American small business and American internet. I think this is just Google turning over the rock, saying, hey, look at all the really, really cool things for business development that symmetrical gives you. And Verizon is basically saying, I don't want to be left out of this market. I want more of that market. I want more of those customers. I want to try and get rid of some of these black eyes that I've had over the years.
Right. Curtis, this is a fundamental shift, although admittedly for a very small percentage of the users on the internet, of the way they use the internet, because it recognizes that we've moved from being primarily consumers of content and data on the internet to producers, to two-way sharers, to people who can give as much content as we consume. What would this do to enterprise business models? I mean, as these enterprises are fighting for their pieces of the cloud and all the money that's contained within that, don't they have to rethink how they build out their networks if suddenly they have to deal with an exabyte flood up rather than just down?
Well, I think the big question is whether the companies who are dealing with consumers are prepared for all of this, and frankly, whether the ISPs are going to keep the same sort of bandwidth limits in terms of the overall volume of bits you move each month in place. I mean, let's admit, if you are doing lots of uploads, you're going to start getting nasty grams from your ISP if they keep those limits in place. I know I ran into that the first month that I had my cloud backup service in place. I started backing up my entire hard disk and I got a nasty gram from my ISP. To me, the killer driver for all this is the same thing that's driving so much mobile bandwidth, and that is video communication. Skype, Google Hangouts, all of that, it eats up bandwidth, and people notice that the bandwidth sent upstream from a particular source is just as important to the overall communication quality as what they're getting downstream. You know, we really have entered the world of the Jetsons when it comes to communication, and we haven't noticed. This kind of Skype or Google Hangout-based communication is happening more and more often. And if you look at the overall bandwidth profiles, you're going to see that's the kind of use where people are going to get into it. And I'll bet that we're going to start seeing some of these telephone-based ISPs start to incorporate that into some sort of plan that we'll be seeing in the next couple of years.
Chee, I want to throw the last question to you. We've got people in the chat room who are saying, more important is data caps than symmetrical data. But I see this as a positive move. I mean, especially if this really is a response to the disruptive force that is Google Fiber. I like this, right? I mean, this can only be good. This is good for the user. This is good for the enterprise. Giving us faster two-way pipes is always a positive move, even if it means that next we have to rail against data caps or the next thing, right? I mean, this is positive motion, right?
Well, also keep in mind, remember, for every TCP packet sent, there's an awful lot of conversation that the stack in your computer and your target computer has to exchange. So having a symmetrical symmetrical upload download means your TCP connections are going to work a heck of a lot better. Lots and lots of video have gone UDP because of this type of thing. They don't have as much bandwidth coming up, so you can't reply as quickly, or you can't reply as often. UDP works great, but it is send and forget. TCP is nice because you have an acknowledgement. So yeah, caps are going to be a bummer, but at least I'll be able to use up to my caps. Right now on my cable modem, I can't even use my full bandwidth because of all kinds of weirdness happening. Yeah, it's probably kids in the neighborhood doing BitTorrents hogging up all the bandwidth, but I've never been able to use all the way up to my caps, and some of it is because my TCP connections can't answer back fast enough.
Wow, that's actually something that I bet a lot of people aren't thinking about. And by the way, I think you just came up with a show title, Up to My Caps in Bandwidth. Now, when we come back, we're bringing on Andrew Warfield. He's the CTO of Coho Data. He's going to be talking to us about web scalable data. If you've ever thought about infinitely scaling up your storage plant, you're not going to want to miss it. But before that, I thought it might be a good time to take a break and talk about the first sponsor of the Twilight Riot, and that's Prosper. Now, what would you do if you knew that in 72 hours you could have $35,000 to cover your needs? Well, what would you do with that 35 grand? Would you pay off your high-rate credit cards? Would you finally do that home improvement project that you've been putting off year after year? Would you start a business? Well, what if I told you that by filling out an easy online application and providing a few details, you could see a rate online instantly without ever stepping foot in a bank? Well, no, that's not fantasy. That's Prosper. Prosper offers low fixed rates, unsecured personal loans, which means no collateral required, and has multi-year terms available. I remember a long time ago when my computer consultation company grew past my resources, it was a success, but I needed cash, which meant that I needed to get a loan from a bank. And that process was as demeaning as it was confusing, showing one bank manager after another that my business, which was this technology thing that they didn't understand, wasn't just cash positive, but profit flush with a need for just enough cash to fulfill my existing contracts. I wish Prosper had existed back then, because then I could have saved myself the wear and tear and the embarrassment of the bank shuffle and gotten the cash that I needed immediately. Prosper is an innovative peer-to-peer lending process, Silicon Valley's answer to the more modern community-based personal loan. There are no outrageous fees, no raising interest rates, and yes, you'll never set foot in a bank. Prosper has more than 2 million members, lenders, and borrowers, and over $1 billion in funded loans. Folks, this is peer-to-peer lending. Prosper connects people who need money with those who have money to loan. It's so simple. It's baffling that this isn't the way that we all do business with our banks. Just go to prosper.com/twit and check your rate instantly without affecting your credit score. So here's what we want you to do. For a limited time, Prosper is offering Twit viewers a $50 Visa prepaid card when you get a loan. Go to prosper.com/twit. That's a special site just for our viewers. Up to $35,000 in just 3 days and a $50 Visa prepaid card. Go to prosper.com/twit. And we thank Prosper for their support of This Week in Enterprise Tech. Let's get to the meat of the show. We welcome to This Week in Enterprise Tech Andrew Warfield, the CTO and co-founder of Coho Data. Andrew, thank you very much for talking to us.
Having me on the show.
All right. Andrew, for the folks at home, could you tell them a little bit about who you are, what Coho Data is, and how you came to be their co-founder and CTO?
Sure. I guess I've been in technology for a long time. I did my graduate school in the UK, where I was one of the guys that worked on the Zen hypervisor out of the computer lab at Cambridge. We did a startup around Zen called ZenSource that was eventually acquired by Citrix. And then I left to be a prof again. I went back to being a prof at UBC in Vancouver. And so a few years ago, we decided to start a company looking at some interesting changes that we saw happening around the landscape of enterprise storage. And we've done that. So the company is based in Sunnyvale in Vancouver. And I'm with the engineering team up here in Vancouver.
Actually, let's talk a little bit about that. What were those things that you saw about enterprise storage that most piqued your interest?
Okay. Well, so with the work that we did on Zen, it was kind of interesting to see how some of that stuff came together. Because on one hand, I was working with the open source project, and we were working with a bunch of companies that ended up being sort of the first public cloud companies, right? Like Amazon and Rackspace, that were taking the Zen source and building big public clouds with it. And on the other hand, we were sort of packaging it up with the startup to sell as an enterprise product. And storage in those two environments was totally different. The public cloud guys just weren't able to take advantage of a lot of the enterprise storage offerings that they could buy. They had to go and build huge systems out of commodity hardware. And so we sort of watched those systems evolve. We watched some of the changes that we've seen happening in technology, especially around flash and networking, and kind of came to the opinion that there's a pretty interesting opportunity to rethink the way storage is done for enterprise environments.
Now, let's talk a little bit about your vision for storage. Coho Data is based around this idea of web scaling. Mm-hmm. Well, what is web scaling?
That's a terrible term. Super markety stuff. Well, so I think, the thing that I guess a lot of the analysts are talking to when they talk about web scale is simply the idea that a bunch of these large environments like Google and Facebook and Amazon have been able to build really, really huge systems, web scale systems, I guess they call them, out of commodity parts, right? They've taken a whole bunch of relatively simple servers and they've built, petabyte and larger storage systems. From an enterprise perspective, the ability to build a absolutely enormous Google-sized storage system is maybe less attractive than the ability to scale the system you do have progressively. And so we've really been trying to take advantage of some of the techniques that the larger data center companies have built around scale, and make those techniques practical for potentially smaller enterprise environments. So not super small environments, but the mid to large enterprise space.
Right. Now, when I hear about web scale, I normally hear two buzzwords, and hopefully you can help me cut through the buzzwords. I hear about horizontal scaling, and I hear about shared nothing architecture. Sounds great, and I've read the brochure, so I kind of understand what they're talking about. But can you break it down? What do those two things actually mean?
Well, so horizontal scaling is a pretty straightforward one, and I guess both of these are pretty related terms. Do you mind if I talk a little bit about Flash for a second in order to motivate this?
Of course, do it.
So we started looking at some of the emerging Flash technologies a few years ago, and in particular, we've had SSDs for over a decade, but the SSDs are moving, right? They're moving off of the traditional hard disk drive bus in the form of SAS or SATA and onto the faster PCIe and even DIMM slots that main memory is on. And so the technology is kind of the same, but the connectivity is getting a lot richer. It's kind of what you were talking about in the earlier segment around symmetric high-speed access to network, right? Inside the host, you're getting much better connectivity to your memory. And one of the very, very immediate results of that is PCIe flash devices are so fast that a single flash device can saturate a 10 gig network connection. And as we go forward and move to 40 and 100 gig network connectivity, flash is going to keep pace with that. And so you'll see flash devices on their own that can saturate entirely their connection to the data center network. And this single property of these memories really means that you have to think about how you build storage systems, because disks have historically been so slow that you don't really worry about the controller that's sitting on top of them. Right? By and large, in storage systems, you take a fairly capable controller, you make it redundant, and you just stack piles and piles of disks behind it. Mm-hmm. But with these faster non-volatile devices like PCIe flash, you immediately saturate the network and you overwhelm the CPU that's driving the thing. And so the idea behind horizontal scale is rather than scaling down underneath that single controller, the devices are so fast that you have to scale sideways. You have to think about the amount of compute that's needed to scale storage and the amount of connectivity that's needed to expose its performance out to the network. And so that's sort of the horizontal idea, is that you need to be able to move sideways with all of your resources and not just the bottom of the stack.
I think one of the first companies to really sort of scrape the edges of that vertical pipe was Fusion IO. And I remember the first iterations of Fusion IO, you really did run into that connectivity problem, even if you were connecting them to switches at the top of the rack, where, yeah, the flash device itself may be really, really fast, but it can't get any further past than the network interface. Let me talk about the difference between web scale and, say, the more traditional server-based, hardware-based storage solutions. And I think your flash story fits in perfect here, because what I've seen from some other companies is they've taken some of their most popular storage systems, enterprise-class systems, and just instead of putting rotating drives, they've plugged in enterprise-class flash drives. And as you've said, you're really kind of bottlenecking the devices themselves. Is that the only difference between web scale and traditional, or does it go beyond?
I think that especially around flash, there's some other pretty significant differences, and they're not all necessarily technical ones. So a really good example of that, of the example that you talk about, is that, you know, there's a bunch of, and it's a totally sensible thing for them to have done, you know, having been array vendors. But there's lots of companies that build arrays that have basically replaced the disks with flash, as you say. So you've got the same architecture, and there are sort of challenges around that end of things. But there's also this economic thing, which is that disks, spinning disks, haven't actually gotten cheaper from a performance perspective for a really, really long time. In fact, most, you know, conventional spinning arrays today short stroke the disks still. They use the smallest disks they can go and get, because the disks have gotten larger, but the number of seeks that you get in a second hasn't improved. And so at a 5-year purchase sort of horizon, when you replace your storage system every 5 years, the new system that you're replacing it with isn't necessarily very much faster, right? It may have a lot more capacity, but it's not really speeding up. The weird thing with flash is that flash is actually still getting Moore's Law style economics, right? Every 18 to 24 months, at the same price, it's twice as fast and twice as big. And so one of the real motivations to build the ability to scale a system out dynamically in building enterprise storage now is that if you have to commit to a 5-year purchase, 2 years from now, you're going to be pretty frustrated with the unused capacity that you spent on.
Wow. Okay. Well, so is that the only difference between web scale and traditional? The fact that you could do this horizontal scaling and actually take advantage of the speed of the hardware you're purchasing? Or is there something more? I understand, again, I'm going to refer back to the brochure that I read, that this sort of horizontal scaling lends itself to simplified storage tiers. How does that work?
Well, so I guess the nature of scaling systems out in this way is that, you know, you want to be able to virtualize the resources, and since you're going to be adding hardware over time, you don't want to burden the administrator with a whole bunch of extra work around maintaining those extra resources. So, you know, one of the things that we saw with the work that we did on building Zen and doing early stuff around virtualization was that when we initially started the work, we thought the real benefit was a really nerdy technical thing. It was that we were going to drive a lot more utilization to the CPU. And one of the things that we saw people really enjoying with virtualization and taking advantage of was the fact that by decoupling the hardware from the software that was running on it, you could turn, you know, one kind of overloaded job into two, right? You could have one person that managed the physical resources and another person that actually managed the individual VMs, right? And in many cases, that was a lot of different people on a per VM basis. And storage is kind of the same way. If you look at the way that a lot of storage systems are built today, you know, the storage administrator is really involved both on the physical side and on the workload understanding and performance tuning side of things. And as you start to deal with burdening them with the need to take on scale and build and maintain the system over time, you know, the idea behind web scale, I guess, is that you want to automate and simplify as much of that physical management as you can, right? The job of the administrator should be much more around offering good performance and helping their customers understand how well their workloads are working and how to fix them, then it should be doing migrations of data and a lot of physical upgrades and things like that.
So WebScale is really, it's storage SDN. It's the ability to create processes, services, and then spin them up and have a backend determine where you need to draw your storage resources from.
Absolutely.
Okay,
Absolutely.
right. Now, if we were going to, again, if I were going to push you and say, all right, I'm considering a WebScale deployment and I'm considering a traditional in-rack colo storage center, what would be the advantages and disadvantages of WebScale?
Okay. So I got to say, I cringe at this term. These marketing terms drive me crazy.
I know.
I'm gonna keep entertaining.
No, break them out. It's fine. Break out. I love when people break out of the marketing.
So let's talk about this WebScale thing a little bit. Like I don't like the term, but certainly.
What do you want to call it? What would you?
I don't have a better term. So I guess I can't complain too loudly.
Storage SDN. I mean,
it's all overloaded stuff. But let's think about the experience that you get leasing storage from a cloud provider, right? You get storage from Amazon's Elastic Block Store, S3, or Google or the Azure Blob Store, any of these things. Right. One thing that is clearly different about that experience as admittedly an end customer, right, typically a home user or a small administrator, versus buying a piece of storage hardware, is that with the sort of lease service, that data is being provided to you over potentially decades. That you're not worrying about the fact that Google has to replace servers under your feet and stuff like that. Whereas if you go and buy a NFS target or iSCSI target or any kind of conventional enterprise storage, you're immediately, the day after you buy it, if not before, worrying about what comes next, what you're going to do with that data 5 years from now when the service on the device ends and you have to replace it with something else. And so from a WebScale perspective, I think one of the biggest interesting aspects of that term is that you should be able to worry about the data that you provide in your enterprise much more as a service than as something that sits on a washing machine that you've bought and stuck in the corner.
Yeah. Andrew, I want to give you time now to do your demonstration. So if you go and start setting that up, I'm going to bring in my other host here to chit-chat a little bit. Chee, has the University of Hawaii looked at doing any WebScale deployment?
The University of Hawaii hasn't looked at a lot of stuff. They're they're a little behind the times. They're nice people, but they're trying to support an awful lot of resource, a lot of researchers that have a lot of demands, and they're not giving them the resources, or they're not making as good use of the resources as they possibly could. Is it something that they're probably going to go with? I don't know. The reality is the University of Hawaii, as far as that goes, I'm a mushroom. Now, is the research groups looking at it? You betcha we're looking at it, especially for MPI, high performance computing. The biggest bottleneck on a lot of HPC clusters is the I/O. And people have been buying bigger and bigger and faster fiber channel and iSCSI and all this kind of good stuff. And a lot of folks are hitting the limits. So anyone that's doing high performance computing has to be looking at something like this, because moving data around, especially for very large projects, genetics, genomics, that type of thing, you're gonna have I/O problems. It's no longer processor, it's all I/O.
Curtis, I want to throw something over to you, and that is Andrew chafes at all the PR and marketing speak. And actually, yeah, we all kind of do. I mean, if you've worked in the field, even something like cloud, I know that so many of us hate calling it cloud services because it's really just a colo, but this is sort of a necessary thing for executives, right? For CIOs, for less informed CTOs. They need to hear things like WebScale. They need to hear things like cloud, SD, and storage services. Is there a better way to communicate the ideas behind this kind of massively parallel, massively expandable storage?
I'm not really sure that there are. I think the terms that we've been using, marketing-oriented though they are, get the point across pretty well. And you're right, there are a lot of subtleties in this that the executives tend not to get. And part of it is because they just have so darned much to think about. They really can't devote all of their time to learning about the intricacies of enterprise storage. That's why they have storage architects. That's why they have IT managers. That's why they have the people whose job it is to spend their time living in these worlds and then know enough to explain it in very simple terms to the people who will actually write the checks. Marketing speak is irritating, but in situations like that, it really can be awfully, awfully handy.
Fantastic. Andrew, let's go back to you. You've got Coho Data's service on a demo machine. Do you want to guide us through some of the functions, some of the features that are built in, and maybe demonstrate some of the principles that we just talked about?
Sure. Can you see the screen that I'm sharing right now?
Absolutely.
All right, great. And so this thing that I'm going to show you is actually not the product UI. It's more to illustrate how some of the system that we built works. And so as I mentioned before, one of the early lessons that we had, interestingly, it was using the early Fusion IO hardware that you mentioned initially on the call, was that we were able to saturate a 10 gig NIC with a single device. And so building a big RAID set behind that NIC using 6 or more devices was potentially leaving a lot of performance on the table, right, that you couldn't expose that extra performance. And so what we did here was we decided to move to an architecture where we balanced the amount of network connectivity, CPU, and high-performance storage in a sort of balanced trio. And so that's what we have here. I'm showing you a sort of model of our system. The base unit is a 2U storage node that's 2 servers. So you can kind of, if you imagine your rack flipped on its side here, these 4 boxes are actually 4 10 gig ports, each with a CPU and a physical CPU and a PCIe card, flash card sitting behind it. And we have a tier of disks in behind that as well. So this column is effectively a 2U device with 4 10 gig cables into it. And so this deployment is effectively a 6U deployment. One of the things that we kind of did with the implementation was to actually converge the storage devices with the network. And so we include a 10 gig software-defined network switch in the product. And so your client machines plug into the switch, and all of these storage ports plug into the switch as well. And that lets us move the storage presentation, which is NFS currently, out to that switch. So you see one IP address, even though that traffic is being drawn back across loads and loads of storage nodes as you scale the system out. And so inside this, right, if I go inside here, this is a VMware deployment, so I've got a bunch of VMs. I can zoom in on these things over on the side. And so here's a VMDK. And rather than combining all of these storage devices up into a big, Razor-coded chunk of stuff or a giant RAID, instead we map down from the VMDK. And so what you see here is this VMDK is actually, it's striped into 8 stripes, and each of those stripes is replicated twice. And as you were talking about on the sort of software-defined end of things earlier, there's basically a brain, a controller in the middle of the system that manages the placement of all of these things across all of the nodes. And so what that means is when you go and run into a need to grow the system, right? You need to add more capacity or performance. You can come in and do that. You can add another 2U chassis. This will add 4 more nodes. And that brain looks at the placement of everything, and it looks at the load on the system, and it schedules work in the background to move that data around under your feet. Right? It rebalances the system in response to load. And so that example of me growing the system is just me racking a new machine and plugging in 4 wires. Right? There's no UI involvement or anything like that in terms of deciding what should go where. And what I've done is I've not only added a whole bunch more storage to the system, but I've actually added an extra 40 gigabits of connectivity. And so the connections and the access to storage scale up alongside the data itself.
What's responsible for the repartitioning of storage? Is that contained in the controller, or is that in the switch? The logic for that lives in a central controller. It's sort of a service that runs in the background on the cluster. And so wow.
Yeah, it's a central. It's a highly available service. Sorry.
Yeah, I was about to say this does automatic high availability, right? If clusters go down, it will automatically reassign itself to give redundancy on existing clusters.
That's right.
Oh, that's fantastic.
That's exactly right. So let me show you another thing that's kind of interesting about it. If you go back to the UI for a second, in the same way that we can kind of scale out and manage that sort of availability, right? If one of these nodes dies, if I look at where the data is on it, these gray lines are indicating failure domains in the system. So we do this to make sure that we never put replicas of data on the same power supply, for example. And so you see that the bits of these stripes are spread across a bunch of other servers. And so if I click this button to simulate bursting this node into flames, right, all of those nodes are able to participate in the recovery. And so the recovery of the system happens faster as the system scales up. And so that's like quite a nice property of the way that the architecture sort of grows.
What's the limit on the number of clusters that you can take control of?
Well, so as you sort of alluded to before, we are a sort of horizontally scalable system, and so we're kind of limited right now by the sort of test resources we have internally. And so we test currently up to a 20 node install. And we're in the process of growing that up to a 40 node install. It's fairly demanding on hardware to run those tests.
Yeah, I can imagine. What's the effective maximum throughput that you can get on something like this? And what's the limiter? The limiter is going to be the CPU, right?
The limiter, interestingly, ends up being the connectivity of your clients.
Oh.
Right. So it's each of these units of storage that you see on the back end is a bunch of flash with 10 gigabits a second of connectivity into it. And so as you scale that out, that grows out along the switch. If you saturate the switch, you can add a second switch and stack them. But obviously, the bottleneck ends up moving out to the individual clients that are accessing storage. So you need to be able to build a sufficiently large client system to take advantage of the connectivity on that side.
Right. Right. Now, we've got a good question from the chat room. Who is this? This is from Virtualized Geek, who wants to know if you're using OpenFlow to control the data plane.
We are. That's a great question. So OpenFlow, for your listeners that don't know about this end of things, OpenFlow is an API that basically lets you have access to lower levels on the switch than has traditionally been possible. So normally with an Ethernet switch, you sort of plug the thing, set up your VLANs, and let it run spanning tree to make sure that it's not creating loops and so on. OpenFlow is part of this idea of software-defined networking, right? It's the idea that if you control a whole bunch of switches, you can do much more precise management of traffic and so on by programming the paths that each individual TCP flow, for example, takes through all those switches. In our case, OpenFlow means that irrespective of whether or not a given customer network has deployed SDN switching, we can include a switch in the product, and we can very directly manage how traffic goes through that switch. So we can use a commodity Ethernet switch in the same way, actually in a more flexible way than historically storage vendors have done with things like Fibre Channel. Mm-hmm. So there's like a really great sort of economics and flexibility to that.
Yeah. This would be an ideal product to be able to place in, say, an interconnect, right? Picking one of the basements around the country that store all the interconnects between the large social media services, the big data services. If you could get it there, then the client connection limitation is not as pronounced.
Yes, certainly. It's also the sort of thing that one of the types of customer that we tend to get a lot of interest in are customers who have a fairly significant scale, a lot of large enterprises or ISP environments. But not sufficient scale to hire a team of developers the way that like a Google or an Amazon have done to build them a storage system. And in many cases, they've tried to build something, but found out that it was a fair bit of work to pull off.
Andrew, one of the scenarios that we always toss to our visitors, to our guests, is the idea of the 10,000-seat network. It's our test case, our imaginary network. Right. If someone was building out a 10,000-seat enterprise-class network, and of course, if it's that large, it also means that they've got satellite offices, they've got services overseas, they've got branch remote offices.
Absolutely.
What would be the advice that you give? And how would you tell an executive this is a solution that you should consider over traditional media, over traditional storage that you may have in your rack. You kind of want this horizontally scalable service available in the web.
Okay, well, sure. So let me show you one other quick thing while I answer that question. If you flip back to the demo, this is actually the product UI on that end of things. So one of the things that was a bit of a pet peeve of mine approaching storage as we went into this is that all of the storage systems that I've worked with in the past, from a UI perspective, look a lot like the Wi-Fi home router that I have from 1994. Or whatever. They're awful UIs, and we really took a lot of pain to make this more decoupled from the hardware end of things and make it more of a service-oriented thing. And so the thing that I would sort of propose to that CIO that's looking at these systems is as a vendor that you're looking to talk to around purchasing storage or building out that 10,000 seat network, what is the timeline that the system is anticipating? Because if the timeline that the system is anticipating is 5 years and you've got 10,000 seats, there's a lot of change that's not being addressed. And so with this system, we've really spent a lot of time anticipating the fact that the hardware that we install this year is going to be augmented on a quarter-by-quarter basis. In fact, as a younger company on storage, it's not realistic for us to sell into huge $5 million, $10 million installs, even though the system's built to scale to that. And the thing that we really see right now is the customers that are coming to us are coming in the middle of their refreshes on much larger storage systems. And they're buying a much smaller amount of our storage as a sort of scalable web scale style product. And they move really performance challenging workloads onto it. So we're installed alongside the incumbent off cycle. And those customers seem to be coming back quarter by quarter and slowly growing the system. And the thing that they really like about it is that as pretty much everything we build is software-based, right? We work on top of whatever commodity hardware is appropriate at the time. They're able to take advantage of evolutions in hardware as those happen. That's a big web scale sort of idea. And that as individual pieces reach the end of those sort of 5-year times that it's reasonable to run hardware for, the rest of the system's virtualized. So you can offline nodes and move data onto other existing nodes that are installed alongside. And you can move those nodes that are close to end of life into test or dev type roles where they're maybe less critical in terms of their uptime. So I think it's really thinking about the future that you want to be thinking about if you're thinking about designing systems at that scale.
So starts less expensively, scales more quickly, has the ability to basically be infinite in the amount of storage that you can assign to your resources. That's actually a pretty dang easy sell. Why isn't everyone using this?
Well, we're just starting to sell. We're a couple of quarters in on the sales side of things, but it's been a pretty good reaction we've had so far.
Now, a geek question of my own. I know that you work a lot with Arista, and they've got their new 100 gig backbone switches. Are you going to be scaling up Coho Data's arrays so that you can take advantage of that?
Absolutely. The stuff we've seen happening on the SSD performance side, we work really closely with vendors on both the flash and the SDN side of things. And one of the bits of this that's really exciting for me, I come from a systems research background, and I did a lot of my graduate school and early research career through a time when CPUs were getting ridiculously faster year on year. And there was a lot of great research around stuff you could do with all that extra performance. And right now we're in this really weird time where the CPUs are relatively static. They're getting a bit more parallel, but they're kind of a fixed target. But I/O and memory connectivity, both in terms of the network and the non-volatile storage, is increasing in almost lockstep and incredibly quickly. So it's a really exciting time to see things like the Arista spine improvements, as well as all the improvements that are coming out on the flash vendor side of things.
Let me go back to my co-host, Cheebert. I know that you're drooling. I've seen you in the chat room just saying you want this. I know you want this. And yes, actually, you're in love with it. Thank you very much. Now, when we were working at Interop, we've dealt with vendors who said they did SDN storage. And it was interesting. Technically, it was interesting. It was a good idea. But it never made all that much sense to me if they were using traditional arrays, even traditional flash-based arrays. This actually makes sense for SDN, right? I mean, this is kind of the promise of SDN fulfilled. You combine this with VDI, and now you have infinitely scalable infrastructure and infinitely scalable storage. This is something that could quite possibly take over enterprise, yes?
Well, not only that, you know, in chatting with the various folks in the chat room, I'm thinking, gee, you know, the bottleneck is the clients. You know, I did some early research into ATA over Ethernet, and man, oh man, we could do some interesting things in VDI, and even going beyond something like an iSCSI driver into the workstations. This could be very interesting. And having, say, for instance, an SDN solution that brings iSCSI or something like that, some IP-based storage solution that can connect into SDN, just boggles the mind in what might be possible.
Right. Curtis, we always talk about that 10,000 seat enterprise network, but I got to thinking, maybe that's not the perfect audience for this, because those companies are going to be entrenched. Maybe, as Andrew was saying, your key demographic are going to be the startups who want something that's affordable yet fast and infinitely scalable. I mean, it's not that it can't serve the 10,000 seat network. Maybe this is designed to serve the future 10,000 seat network and start off with the 5-seat startup. Oh, well, what's your thoughts on that?
Well, I certainly think that something like this could be a nice competition to the cloud storage that a lot of those startups are using today. It has a lot of benefits over a pure provisioned, you know, cloud solution. I think that where things get interesting is when you look at very large enterprises, or in today's language, enterprises with exceptionally large data requirements. I had it pointed out to me recently that these days you can't make a direct correlation between number of seats and size of storage requirement. So I think what you're going to see are some companies that have been turning to cloud providers for some of their maybe tier 3 storage, looking at something like this to see if they can bring more of that storage inside, start to tier it intelligently, but improve the performance of the overall storage infrastructure while they gain some control and shift some of the expense from operating expenses to capital expenses.
Right. Andrew, I want to throw you the last question, because unfortunately we have really reached the end of our hour. And that is, if you could define what storage was going to look like in the next 5 years, where would you want to see Coho's technology used? I mean, of course, you'd want it distributed in data centers across the world. You'd want people to be able to pull resources from clusters that are geographically close to them to increase decrease the amount of latency, increase the amount of available bandwidth. But where do you see this scaling? I mean, where do you see the technology ending?
Well, I guess that's kind of a big question for the last question of the hour. But I guess I'd like to make a lot of the problems that storage administrators have historically dealt with kind of go away. And I guess that's the move from a product to a service style offering. But again, as we look at the way that these technologies are shifting, I really see storage being less and less of something that you think of sitting out somewhere at the edge of your network, where there's, you know, a pile of slow disks and a pretty slow pipe going into it, and something that's much more tightly integrated with all of your compute. And so I think that, you know, while we've put an enormous amount of effort into supporting the legacy interfaces like NFS that make data centers work today, that as we go forward into the next 5 years, that the performance realities of these things are going to move those interfaces closer and closer to applications. And I'd really like to see us providing that sort of unconstrained access to storage as we move forward.
Thank you. That's Andrew Warfield, the co-founder and CTO of Coho Data. We thank you for joining us.
Thank you.
Now, we also want to thank our entire panel for joining us for this hour of the best dang podcast, enterprise podcast in the universe, according to 9 out of 10 flash storage arrays. I want to give all of our panelists a little time here to talk about what they're doing, what their projects are. Chee, can you tell the Twiat Riot what you'll be doing the next couple of weeks?
I am finally going to be finishing up the video wall build at the Department of Emergency Management and trying to get all these things going. And a shout out to the guys at Extron. I'm going to be in a class next week to learn how to program all their doodads.
Doodads indeed. Curtis from Information Week, can you tell people what's going on at Information Week Radio?
Well, tomorrow we have a program that should be of interest to a lot of folks. You know, it's one thing to know the technology, but we're talking about women in IT, and tomorrow we're going to be talking about something specific that actually will apply to a lot of men, and that's how to negotiate the salary that you deserve. That's at 2 p.m. Eastern Time over at Information Week Radio. Love to have folks show up and join us and give us your thoughts on negotiating salary. Then on August 1st, that's Friday, August 1st, I've got a special program with the director of the U.S. Fish and Wildlife Service. We're going to be talking about how Fish and Wildlife uses high-tech and social media to get the word out about the natural resources of this great country of ours. I'd love to have lots of people show up and pepper the U.S. Fish and Wildlife Service with your questions.
And last but not least, Mr. Andrew Warfield. Andrew, if you could tell the Twiat Riot where they can find you, where they can find out more information about Coho Data, and maybe even where they could talk to one of your representatives about demoing this most incredible flash storage system.
Sure. They can find me on Twitter. My Twitter handle's in the lower third there. In terms of finding out more about the company, we're at cohodata.com, and I think the right email address to send mail to if you're interested is just learn more at cohodata.com.
And who doesn't like to learn more? Thank you, one and all, to our panelists. And also thanks to you, our loyal watcher, listener, our audience member, the person who downloads Twiat each week, because without you, we don't have a show. Well, we want to make it easier for you to get the show. In fact, we want to make it easier for you to share the show with others. That's right. We want to grow our audience. If you've got a friend who's in IT, if you've got a friend who's in the enterprise, or even if you've got a friend who might be interested in what goes on in networks, data closets, and colos across the world, why not direct them to twit.tv/Twiat. That's our show page. There you'll find all of our episodes, as well as a little drop-down menu that will allow you to automatically download episodes of Twiat to your device of choice. If you want it in your iPod, your iPad, your iPhone, your Android tablet, your PC, your Mac, whatever it might be, we've got a selection for you. If you want to listen to your car, why not download the audio file? If you want to watch it on your tablet, download the video file. And if you want to watch it at home because, hey, Twiat's some good lovin' on your big screen TV, why not download the high-definition stream? It's all for you. Also, please follow me on Twitter. You can find me at twitter.com/PadreSJ. That's at PadreSJ. If you follow me, you'll find out what we're going to be doing each week in every episode of This Week in Enterprise Tech. And you'll also see what else I do on the Twit TV network, including my shows on Thursday, Know-How and Coding 101, and my show on Friday, Padre's Corner. It's all just a moment away. Follow me at PadreSJ. Finally, did you know that we do the show live? Yeah, live every Monday at 2:30 Pacific time. You're going to find us at live.twit.tv. If you watch live, you get to see the pre-show, the post-show, and all the bloopers that we take out of the final download. It's just a reward, something that we give to the extra special members who are part of the Twit Army. And as long as you're watching us live, why not jump into the chat room at irc.twit.tv? It's filled with some incredibly bright people, some of the funniest trolls, and yes, some of the best members of the Twit Army. It's all at irc.twit.tv. Finally, I want to thank everyone here at the Brick House who makes this show possible, to Lisa, to Leo, to Carson, my super producer, and to my musical TD. Today, it's Patrick Delahanty. Patrick, can you tell the folks where they might be able to find you on the Twit TV network?
I've got 2 more episodes of Coding 101, and yeah, that's what I do here.
And then he'll be taking over as host for Know-How, because we're firing that bum, Brian, who was supposed to be sitting at the TD desk, but evidently he's too good for us. In any case, I'm Father Robert Ballecer, and I want to remind you that if you want to know what's going on in the enterprise, just keep Twiat.